Yeah, perfect. Well, why don't you take it then? Looks like we are seeing your screen right now. Why don't you tell us a little bit about what your project involves?
I hope it doesn't take too long anyway. But, yeah, the traditional drawing is done with planning frames and drawing boards and pencils, and you can see images here of people working away trying to recreate a graphical representation of the sites they're digging. And you can see from these images that it's quite a difficult process to get a drawing which actually represents the whole site, especially as one with lots of different people drawing. So you've got lots of drawing scales and styles being used, and how you represent them into the finished drawing is the problem. So this is an example from about 1977, and the drawing on the left is the end product that we want to put in a publication, which is a line drawing showing the development of the site, all the different features and the features numbers, and it's sort of illustrated on the right hand side. I estimate that that's taken a month to draw that image, because again in 1977 it will be hand drawn, and it would take time to redraw something, copy it, scale it, and everything else. So the obvious solution is some form of photogrammetry, and this image from North Wales, I know that work was carried out in 1999 because I was involved in it, and the photography was carried out with a mast about 4 meters tall. The camera sat on the top of it, and we had to move the camera and the mast around the site taking photographs. And then the guy took the film away, processed it, scanned it, put it together, and generated something like this. But it took a week to do that. And nowadays we can generate that image very quickly using drones or cameras on poles, put it through photogrammetric software, and produce those images. The drawing of the site on the right is probably also done by hand, because you know, sort of archaeology is very safety conscious. We like to have everything on paper, so it's a bit of an issue there with that. But it's an illustration of, you've got two views there, one showing what the site looks like, and the other one with the interpretive view of what's going on the site. So this is a site in Azerbaijan where I was working, and the photograph is generated from photographs from a camera mounted on a pole, and then generated through photogrammetric software. And then the line drawing has been created in a drawing software as a traced thing. So it's not, again, there's a huge amount of work and time taken up in generating that part of it. But that's sort of where the software had got and the processor got by about 2016. In the last couple of years, I've been working on a road scheme in West Wales, and we have adopted drones and so forth. And the sort of large image up there shows the site being excavated, and the process in there. It's a Neolithic site, and it's a palisaded enclosure. And if you look closely inside, you can see little post holes inside these trenches. And then that's an ordinary photograph from a drone. The image on this side here is a photogrammetric view, and then converted into a point cloud, which is the lower one here, and then viewed as a shader option in Global Mapper. And the whole image has been rectified using GPS, so it's all to scale. So we have a process. If you use the profile tool in Global Mapper, you can see the undulations of the different gullies that are there. So this portion here is in this area here, and then you move it across. It provides an illustration of what's going on the site, and is very, very close to the optimum image of a line drawing that we're trying to show in that sort of 1977 type of site. we moved on to that. I started playing around with Global Mapper and the blending and showing sort of orthographic images overlaid over the point cloud, either over the point cloud or over the DEM, and then viewing them through different portions. And I ended up coming down to this one on the right hand side, where we can actually see sort of, you can't see in this example very well, but where you have vertical elements in here, they show it very well because the slope shader is showing the information very much steeper angles than the flat stuff. I don't know if I've got an example. Yeah, here, this is a Iron Age roundhouse. It was dug in West Wales on St Bride's Bay. And you can see the site of the roundhouse here, and portions of it there. The DEM image here is shown as a sort of shaded image where the flat surfaces are coloured white up to 15 degrees, and the vertical elements are then shaded in this sort of dark grey up to about 89 to 90 degrees are in dark colours, which is a very good way of showing the slopes and the indentations of the site which are there. And you can see that, you know, in this photograph of the site, there are many sort of settings of stones which are vertical. So you can see the lines of the walls and, that come around here, together with the ditches and gullies which are here, which are formed because there's a high component of slopes in the information. It's showing it quite well. This image then is the orthomosaic laid over the DEM and blended together, which is showing a visual element of it. And if we zoom into it in this view in here, we see this portion is about here, which is a drain inside the site, which is emptying out. And we can see, because we've got texture shown and the high combination of slopes and shadows, it shows up very well, including sort of holes and stones and features like that. So this is how I was working my way through this. This is another site in Azerbaijan. In 2017, we actually did the work. I didn't process it in this form until last year when I was doing my dissertation, but it's a medieval castle, and we've got sort of walls and towers inside there, which wasn't known until we arrived to build a pipeline. And this tower here is this area in here, and again you can see walls along here that come across here, other parts of towers in here. Then there were more parts of it in this way, and these are storage pits and other things of later phases of occupation of the site. But this image, which we sort of call the sepia tone image, is very good at showing a lot of the features that are happening on site, and is very close, I think, to the 1977 optimum that we need. Running the two images side by side allows the two things to be seen, the contrast between something which is actually showing orthomosaic view and something which is giving more indication of relief is a good way of indicating what's going on in there. And you can see from the profile there's quite a degree of changes in height one way or another inside there. Again, back at the road this year, yeah, we've got the machines all lined up waiting to come in. We've got the Archaeology in there, and we have this circular feature just in here, which is this one along here, and then ditches across this way. And again, you can see in the shape file, sorry, not the shape file, the DEM, and the slope shaded one is these drain covers which is being stored here. They show up very well as vertical elements. And again, the other parts, I don't know if it's visible in here, You've got curbstones on the existing road, which are this part here. They show up quite well on the edges of the excavation and section lines, which are something we need to see in archaeology. So then again, another site, you've got the oblique view, and it's a burnt mound with lots and lots of charcoal inside here and stones. And this is the excavated area that we worked in. And you can see the vertical view and the sepia toned view of the DEM. So it's giving a good result in certain sorts of sites. And now I have to sort of point to this one, where again, we've used the same techniques, but the nature of the site is much more vague. And we have some pits in here, a few pits in there, and not very much else. And I'm afraid the end result of this image is not very good in the shaded DEM and the sort of ortho view there. And I think that's something to do with the degree of verticality of the features we're looking at. If we have lots of steep dropped edges, we can see that. There may be different ways of operating this. I don't know yet quite how to overcome the difficulties of this, whether this is about as far as information will go, or maybe you experts in Global Mapper will know how to resolve this. But it's something I need to work on in future. The missing elements that I see, there's no title block, scale, north arrow. I've fallen behind in a lot of doing that. The sepia drawing needs to be converted in some way into a line drawing. And that's the optimum final result that we need, that we can show what's going on, because there's a lot of information which needs to be added. And I suspect that some form of hybrid recording by sketching or small sets of drawings and combining it with this form of recording using cameras or drones and generating this set of information, because it is providing an accurate framework within which to put the other information. And then again, we need to add the GIS information, because all these sites are being dug. The individual parts of them are being described in great detail, numbered and everything else. So we need to find a way of getting a GIS into it. And then, as I mentioned before, the shader options are difficult to control to give really good results. And I suspect that from the examples I'm showing there, both vertical elements and the color of the soil. So the ones which seem to work out well seem to have a pale colored soil, whereas if you've got darker soils, it may not be so easy to use it. And then there is the blended mosaic becoming very dark when it's viewed through the above the DEM. And again, I don't know quite whether there's ways of changing that, but we'll see. Now, part of my work in future is going to be looking at earthwork sites, and these are some barrows. So you've got one here, another one here, another one there, and these show up really well if you use the profile tool. The people are standing in the middle one, and the far one is there. The profile tool shows these perfectly as earthworks and circular tumps in there. And the DEM views of this are not really giving it justice, I think. So it's part again of I think some of the slopes are more like 45 degrees as opposed to 90-degree sites, 90 or 90, 80 or 90-degree angles on an excavated site. And you can see that some of it here, because the site is covered in this heather, and the people who look after the ground have been up and down and mown the material in there. So you can see the sort of ground surface, or what is ground surface, about a foot or so above it will be this heather. And one objective I would like is to be actually remove by classification this heather cover and just leave the ground, which is possibly what the machine is working on. And then the final site, which is about 3 miles from my house. This is a hill fort on the Preseli Mountains. And again, you know, we've got 3 round barrows in the middle of the site. We've got the embankments around the outside of it. And then all these things in here are hut circles. There's approximately 200 hut circles in there, and sets of quarries along the edges here, and quite a number of other features as well. And I would like to go further in my survey and actually identify all of the features and work my way through them. But it's going to take it's a sort of GIS type of operation, combining the images that you can see here and end up with something which will be sort of more informative than what we can see, although this is very useful to look at here. But again, you can possibly see the heather which lies across the site and the sort of various undulations here. And we would like to just get to the soil levels, the ground levels, as opposed to the stuff which is like 18 inches up in here. But there we are. That's about as far as I've gone with it. I think I've managed to do certain things quite well using Global Mapper, but there are other parts which defeat me, and sometimes some masterclass might put me in the right.
Well, at the risk of turning this into a training class, and I know we don't have time, but there are a lot of the questions you brought up. I know, oh, I can do that. I can help you with that. I can help you with that. Fascinating, fascinating use of Global Mapper. So, David, once again, let me congratulate you, and on behalf of all of us here at Blue Marble, well done. It sounds like a work in progress, and we'd be more than happy to work with you as you continue your project. So again, round of applause from the Here Gathered. There we go.
Let me talk about it anyway.
Yeah. Cynthia, you are muted.
I am muted. I'm here talking up a storm. Thank you, David. I was saying thanks to both Davids for joining us today. We have congratulations, David Maynard, once again. And I know that it's a big change in time between us and Wales, so I appreciate you joining us and sticking around.